everybody, I come back yet with another segment. What are we doing today? We'll be looking at Euclidean geometry and the question that we have from one of our previous question papers, question number 7. And here's our diagram, here is our statement, and here is our two questions. All right. They say in the diagram O is the center of the circle, so this is the center of our circle. Rs, V, and W are points on the circle, so if you have points that are on the circle, it makes the figure to be a cyclic quad. Then Rs and Wv are produced to meet at T. Rv and Ws, they intersect at P. And then we have Rsv, which is equal to 20 degrees. It is given here. And then ROW is given as 80 degrees. It is given there. Now let's answer the question. Determine with reason the size of the following angles. So we'll be stating reasons for each of the following angles. The first one they want us to calculate is V1. So V1, where are you? Here is V1. V1 is here. Now we're going to highlight a shape where we find V1. So we'll go so that we can create a theorem behind that, behind our reason, behind our answer, I mean. So if you look at what I'm highlighting here, you will notice one of the famous theorem in Euclidean geometry. Angle at the center is 2 times the angle at the circumference. So if you look at that shape that I have highlighted, it gives us that theorem. So if the angle that we have at the center here, it is 80 degrees, and V1 is at the circumference of the circle, that would mean that V1, it is equal to 40 degrees. Angle at the center is twice the angle at the circumference. So in this case, the angle at the circumference must be 40 degrees so that the angle at the center can be 80 degrees. So V1 here, it is equal to 40. And then our reason, we're going to say that is the angle at the center. That is the angle at the center there, is 2 times the angle where at the circumference. That is the angle at the center is 2 times the angle at the circumference. And then they take us outside the circle, angle T. Angle T out there, we need to find what is the value of that angle. I wanted to erase that. So you will notice that we are in a triangle here. You see the triangle that I am highlighting from R to T, then you go to V, and then you go back to T. You have that triangle. Now within this triangle, you have the angle 20 degrees. We have already established this one here as 40 degrees. Angles on a straight line, V2, wait a minute. That means V2 is 140 degrees. Angles on a straight line, they must give me 180 degrees. So V2 becomes 40 degrees. Then you will notice that you've got 2 angles and 1 angle it is missing there. If you do your calculation, you will see that angle T there, it is equal to 20 degrees in such a way that interior angles of a triangle, they must give us 180 degrees. So how do we answer this one? Here we're going to say V2 is 140 degrees. Why do we say that? This is an angle on a straight line. These are angles on a straight line. Once we have established that V2 is an angle on a straight line, that means angle T, if you add it to angle R there, 20 degrees, and then if you add that to V2, all these, they must give us 180 degrees. These are interior angles of what? Of a triangle. So that means what? That means angle T, it is equal to 180 degrees minus 140 degrees minus the 20 degrees, making angle T to be 20 degrees. That's how we got that angle 20 degrees up there. So angle T, we can safely and confidently say that the angle there, it is 20 degrees. Looking at our last question here, they say show with reason that SPVT is not a cyclic quad. What do you know about a cyclic quad? I know that the opposite angles of a cyclic quad, they must be supplementary. So what does supplementary mean? It means that when you add the opposite angles of a cyclic quad, they must give me 180 degrees. So it means that if I add this angle 20 degrees and this angle at P4, when I add them, they must give me 180 degrees. If I add this angle as 2 and this 140 degrees, when I add them, they must give me 180 degrees. So since we already have V2 as 140 degrees, can we find an opposite angle, say angle S2 here? Can we find angle S2 and establish the size of that angle, and then we add them? If they do not give us 180 degrees, then we would have proven that SPVT is not a cyclic quad. Let me highlight this SPVT for you so that you can clearly see it. You see SPVT. This is the shape we are referring to. And let me write the information that we have established. We have established that V2 here, it is 140 degrees. This one here, it is 40 degrees. We have established that those are angles on a straight line. But wait a minute. S1 must be equal to V1. The angle S1 here must be equal to this one here. What do you notice there? You will see there's that bow tie theorem. So if you move from R, you go to S, and then you go all the way to W, and then you go back to V, from V, and then you go all the way back to R. Do you see that bow tie situation there? These are angles on the same segment. Angles on the same segment, we say that they are equal. So that means S1 is equal to V1, and the value of that angle, it is equal to 40 degrees. These are angles that are on the same segment. Okay, wait a minute. So if S1, it is equal to 40 degrees here, that means S2 must be equal to 140 degrees. So that means S2 must be equal to 140 degrees. If S1 is equal to 40 degrees, these are angles on a straight line. Remember, we said that angles on a straight line, they must give us 180 degrees. So 40 degrees plus 140 degrees, they must be 100. So here, it's 140 here, 140 degrees. These are angles on a straight line. Sharp. So what do we have? We have angle V2, we have angle S2. So that means V2 plus S2. If this shape is supposed to be a cyclic quad, when we add them, they must give us 180 degrees. But we have 140 degrees here, and this one also is 140 degrees. Adding them, it gives us 280 degrees. So that means SPVT is not cyclic. SPVT is not cyclic because the two angles, they are not equal to 180 degrees. This is not equal to 180 degrees. So if the two opposite angles are not 180 degrees, it means that the quadrilateral, it is not a cyclic quad. Thank you very much. Let's catch the next video. Bye-bye.